Multiplying monomials algebraically. Let's evaluate some multiplication questions. So 3 times 4 is 12, and 12 times 5 is 60. For part B, 3 times 5 is 15, and 15 times 4 is 60. For part C, 4 times 5 is 20, and 20 times 3 is 60. So what do you notice about all the answers? You should notice that they are all the same. So even though the questions, the numbers in the questions were in different orders, they all got the same answer because we're all multiplying these terms together. So when the only operation that is involved is multiplication, we can multiply the values in any order. And this property not only makes it easier to multiply numeric values mentally, but it also is critical to simplifying algebraic expressions. So instead of writing repeated multiplication, so this is what we would call in expanded form, of the same value, we can write expressions in simplified form or even in exponential form. So we're going to write each of the following expressions in exponential form. An exponential form is exactly what it sounds like. It involves a expression that uses exponents. So instead of writing 2 times 2 times 2 times 2, we can write this expression as 2 to the power of 4 because there are 4 2's being multiplied together. Instead of writing negative 5 times negative 5 times negative 5, we can write this as negative 5 to the exponent of 3 because there are 3 negative 5's being multiplied together. And instead of writing a times a times a times a times a, we can write this as a to the exponent of 5 because there are 5 a's being multiplied together. So this is what it means by expressing something from expanded form to exponential form. So let's go backwards. So let's write negative 4 to the power of 3 in expanded form. So what does that mean? Well, that means that I'm taking my negative 4 and I'm multiplying by itself 3 times. Negative 4 times negative 4 times negative 4. K squared is the same as k times k because I'm multiplying k by itself 2 times. And lastly, m to the power of 4 is m times m times m times m 4 times. So I'm multiplying 4 by itself 4 times. And you can write your letters using brackets like I did here, or you can write them using a dot up as the question up above that is showing. You can also use it using multiplication symbols like the one in number 2. I caution you not to use a multiplication symbol, so use the x, because sometimes an x is used as the variable and it's easy to get the letter x confused with the multiplication symbol x. So let's do some more examples explaining how we go from expanded form and exponential form. So you'll notice in these expressions, we have 2 terms being multiplied together, and these 2 terms have what we call the same base, so they have the same letter, the same variable. So that's going to be really important. So how do we write b squared? Well, b squared is the same as b times b. How do we write b to the exponent 3 or b cubed? That's the same as writing b times b times b. So I'm multiplying b squared in the expanded form by b cubed in the expanded form. So what that shows us is that I have 5 b's being multiplied together. So in exponential form, this simplifies to 5 to the exponent, or b, sorry, to the exponent 5. The next question uses y. So I have y to the power of 4, or sometimes it's expressed as y to the exponent of 4, times y to the exponent of 5. So I'm going to write my y to the power of 4 in expanded form. So that's y being multiplied by itself 4 times. And I'm going to multiply this by y to the power of 5. So that's 5 y's. So 1, 2, 3, 4, 5. So now that I've written these expressions out in expanded form, I can easily see that they're all the same. So they're all the same letter. And now I can simplify this expression into exponential form. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 y's being multiplied by themselves. So I can express this as y to the exponent of 9. And the last expression that we're going to look at is w to the power of 3 times w. So I'm going to write my w to the power of 3 in expanded form. So that's w being multiplied by itself 3 times, and I'm multiplying that by w. So you'll notice when it's just w, there's nothing that we're writing here. So this is like an exponent of 1 being written there because it's only one w. So that's a way for you to sort of represent a number or a value in exponential form when there is no exponent there. So now I have 1, 2, 3, 4 w's. So I can write this as w to the power of 4. So how can we go directly from our expression to exponential form? So we went from the expression to expanded form and then to exponential form. Well, if we look at our exponents, the numbers in our exponents, in the first one I have 2 and a 3. If I add 2 and 3 together, I get 5. Let's see if that works for the next one. I have y to the exponent 4 times y to the exponent 5. 4 plus 5 gives us 9. And if I look here, I have w to the exponent 3, and we mentioned that a w is just the same as writing w to the exponent 1, and 3 times 1, or 3 plus 1, gives us 4. So we can go directly from the expression to the exponential form by adding the exponents. Now this will only work if the bases are the same. So if the if the letters, the variables are the same. So this only works if the bases are the same. And so that's what we call the b in this one. So the b, it would be the base, and these 2's would be the exponents. So it only works when the bases are the same, so they have to have the same letter or even sometimes the same number, and it's only when we're multiplying. So it only works when this strategy only works to add the exponents when the bases are the same and we are multiplying. So we are multiplying the terms. So this is something that we call an exponent law, this property that we've developed right here. And you'll learn more about exponent laws as you progress through your math career. So now that we've taken a look at multiplying variables, let's sort of put this all together now. So we're going to simplify each of these expressions. So in order to simplify expressions, I want to look at the numbers or the coefficients in my question, sometimes referred to as even a constant. And I also want to look at my variables. So I want to multiply my numbers together. So 4 times 3 gives us 12. And if I have more than one term with a variable or a letter, then I would multiply those together. But I only have the one letter, so I'm going to write 12 and then m to the power of 3. So multiply your coefficients together, and then you look at your variables and simplify those. So let's take a look at part B. I have 2 times 5, those are my coefficients. 2 times 5 gives me 10, and I have h times h. Now if you remember, I have 1h and 1h, and what does that mean? That h times h is the same as h squared, because there are two h's being multiplied together. Let's take a look at part C. So now I have two terms that have a combination of a coefficient and a variable with sometimes an exponent. So we want to look at our coefficients first. So 3 times 4 gives us 12. And now we look at our variables, in this case our a. I have a squared times a. Now remember, this is 1a, so you can write a little 1 there to help you remember that. And so remember when the bases are the same, so they have the same letter, we can add the exponents together to simplify that. So a squared times a, or a to the power of 1, 2 plus 1 gives us 3. Let's go through some more examples so we solidify that. So this time I have a negative 2 times a 5, so that gives me negative 10. And I only have one variable, which is n squared. Part E, 3d times negative 5d. 3 times negative 5 is negative 15, and d times d is d squared. If it's helpful you to put a little 1 with your d's to show that those are the exponents, and 1 plus 1 is 2, then feel free to do that. Or know that you are multiplying two d's together, so that becomes d squared. And whatever strategy works to help you remember these rules will be whatever strategy you're going to use. Next one, negative 3z squared times negative 6z to the power of 6. Negative 3 times negative 6 gives us 18. Remember that two negatives make a positive. And now I look at my variables, so I have the z here. Sometimes you'll see the z little line through the middle, just to distinguish that from a 2. Whichever you prefer to do is fine with me. And I have 2 plus 6, which will give me 8. So you'll notice again that I've used different ways to distinguish or to demonstrate multiplication. So sometimes using the dot and sometimes using brackets. So knowing that these all mean multiplication. So the last two examples, G, I have 4t times negative t. Now, when I have just a letter here, this is like an imaginary 1. So this becomes 4 times negative 1, which gives us negative 4. And t times t is t squared, because there are two t's being multiplied together. And sometimes we'll have more than one term, like we had up in those first few examples. So the number in front of your k, so just a single k in this one, is a 1. So if it helps you to write that in, feel free to do that. 2 times 1 is 2, and 2 times negative 4 is negative 8. And I have k times k times k, so those are 3 k's being multiplied together, so it's k to the exponent of 3. I hope that helps you in terms of multiplying monomials together. So a monomial is just an algebraic expression with one term. In this lesson, we looked at how we can multiply our coefficients together versus our variables. And we also looked at exponent properties when we are multiplying. So when we multiply our exponents, our terms with the exponents, the base will stay the same, so the letter stays the same, and you add your exponents together. So those are some rules to remember when you're multiplying monomials.